Class, we're on our second video lesson for Chapter 11. We're talking about the areas of two different figures today, the areas of triangles and the area of trapezoids. So here, review lesson from yesterday, how do we find the area of a parallelogram? Well, remember, you take the base and you multiply it by the height, and the base and the height are always perpendicular. So if this is the base right here, then this is the height right here. It's that perpendicular distance. Okay? So if you remember from Chapter 8, when we studied parallelograms, what does one diagonal do to a parallelogram? If you hit this blue line as a diagonal, it cuts it in half, cuts it into two congruent triangles. So if that's the case, then let's say that the area of this figure is 30 square units. Well, if one diagonal cuts it in half, this would be 15 and this would be 15. So the area for a triangle, is 1/2 base times the height. It's half of a parallelogram. So we take the base times the height, and then we take half of it. And that's what the area formula is for a triangle. Area equals 1/2 base times height. All right, we should talk about a few things here. There's three different sides of a triangle. So let's say I call this right here the base. What would be the height? The height is the perpendicular distance. So oftentimes what's done on some of these diagrams is they'll show a dotted line that is not part of the triangle, but it shows where the height should be. So this distance right here is the height. It is the perpendicular distance from the base to the top of the triangle. So if we call this the base, the height is right here. Okay, please write that down in your notes. If I call this distance right here the base, we could have this be the base, then the height is the perpendicular distance to the top of the triangle, which would be right there. Now this would be my height. Okay, so we've talked about if this is the base, we've now talked about if this is the base, and in a triangle, we could call this the base, right? If this is the base, where is the height? Well, again, we extend this outside the triangle, and then we extend this right here, and this perpendicular distance right here is going to be the height. So you got to be very careful when you do triangles. The height and the base are always perpendicular, just like parallelograms. All right, it says, calculate the area of this triangle. Well, I know that the area of any triangle is base times height, and it's half of that. 1/2 base times height. So, what is the base? Well, we should always go to a perpendicular intersection because that's where the base and the height are. So if this is 90 degrees, then here is my base, here is my height. The 5.2 and the 13 aren't necessary in this problem. It is 1/2 of base 10 times height 5. Half of 10 times 5. 10 times 5 is 50. Half of 50 is 25. So 25, and we're always going to label with these 25 inches squared, or square inches. There is our area. Take a look at this one. Calculate the area of an equilateral triangle with side lengths of 8 feet. So if it's equilateral, all the sides are congruent, and they're all 8. So the area of a triangle is 1/2 base times height. Well, I know the base. The base is 8. 1/2 times 8. So now my height is what I need to find. Okay? It is not this 8, and it is not this 8. The height is the perpendicular distance, which is this right there. This, friends, is the height. So how do we find this? If this is a 60-degree angle, which it is because in an equilateral triangle, all three angles are 60, and then if I make a 90-degree angle right here, because the base and height are always perpendicular, then this has to be 30. It's our 30, 60, 90 right triangle. So now if this side is 8, it's the hypotenuse. The shortest side, opposite 30, is half as much. So this one is 4. And so what is my height? My height is the square root of 3 longer than the shortest side. So 4 times the square root of 3. There is my height, everybody. My height is 4 root 3. So we're going to answer in two different ways. One is the exact answer. We're going to keep root 3 in our answer. We'll also answer with the approximate. So 1/2 of 8 is 4, and 4 times 4 is 16. So it's 16 root 3, and this is square feet. Or if you want to, you could multiply these two first and get 32. Half of 32 is 16, so again, 16 root 3. If you multiply 16 times the square root of 3, you would get an approximate answer of 27.71 square feet. Okay, both of those two answers I want you to have down. One is the exact answer, the other is the approximate. This time, class, I know what the area is. I'm told that it is 68 inches squared. Let's find the length of what we need to know. The length is the base. It's this distance right here. We could find that length. We see the 90-degree angle, so the base and the height's always perpendicular.
Please report to the computer lab in the media center.
Okay, so we know that the area of a triangle is 1/2 base times height. We know what our area is. Our area is 68. So that equals 1/2. The base is what we want to find, multiplied by the height. And the height is 8. So now we're just going to use algebra to solve for the base. 68 equals 1/2 of 8 is 4. So it is 4 times the base. Divide both sides by 4. And we get the base to equal 68 divided by 4 is 17. 17. And we will label this one in inches. Lengths are in inches. Area is in square inches. Okay, now we're going to talk about the area of a trapezoid. What is the area of a trapezoid? The area is 1/2 of the height times base 1 plus base 2. So here's our two bases. We're going to add those up. Put that in parentheses. Multiply it by the height, and then take 1/2 of it. Once again, like every other figure, the height and the bases are always perpendicular. So don't think that this is the base. This is called the leg of the trapezoid. Don't think this is the height. This is the leg of the trapezoid. The height is the perpendicular distance. So you need these 90-degree angles for that perpendicular distance. Okay, let's find the area of this trapezoid. The area equals 1/2 height, base 1 plus base 2. So 1/2 of the height. The height is this 7-foot length right there. Times the sum of the two bases. The bases are 20 and 10. So 20 plus 10, that makes the number 30. 30 times 7, and then 1/2 of that. 1/2, 7 times 30, and that gives us 105. 105 feet squared. So let's always go back to what this means. If this is 1 square foot right there, there are 105 of these square feet that fit inside this trapezoid. Okay, and that's what area is, 105 square feet. This time it says calculate the length of the missing base if the area is 13.75 meters squared. So again, we're not asking you to find the area. We know what the area is. We want to find one of the bases. We want to find that right there. So the area of a trapezoid is 1/2 times the height, base 1 plus base 2. I know what the area is. Yes. I know what 1/2 is. Yes. I know what the height is. Yes. I know what one of the bases is. Yes. I just got to find this other one. Hoorah! Let's do this thing. 13.75 is the area. That equals 1/2 times the height. We know what that is. It's 2.5. It's the perpendicular distance between the two bases. Woo! We know what one base is. It is 3.5. Let's find this other base. So 3.5 plus base 2, or plus b. Couple different ways that you could solve this one algebraically. I would probably just take 1/2 of 2.5 right here, and that would be 1.25 times 3.5 plus b equals 13.75. Now if you wanted to, you could distribute that 1.25. I think it'd be easier to just divide both sides by 1.25, and then you would get rid of the 1.25 from the right side. So if you take 13.75 and divide it by 1.25, you would get 11. So 11 equals 3.5 plus the other base. So to get the other base by itself, I would subtract 3.5, and I got it made. 11 minus 3.5. The other base is 7.5 meters. This base right here is 7.5 meters long. All right, last one for the day. Calculate the area to the nearest tenth of an isosceles trapezoid with base lengths of 24 and 10 and legs that are 11. All right, if the base lengths are 24, so here's one base of 24, and 10, here's the other base, 10. It says the legs are 11. In an isosceles trapezoid, the definition is that the base, the legs are congruent, and the base angles are also congruent. So this leg is congruent to this leg, and it tells us that they're both 11. All right. So if I want to find the area equals 1/2 times the height, base 1 plus base 2. Well, good news, I know both of the bases. So this base 1 plus base 2 is 10 plus 24. Rats, I don't know the height though, do I? I got to find the height in order to multiply it by the sum of the two bases and by 1/2. So this right here, everybody, is my height. I got to find out how high this is. Okay? So how do we do that, you might ask, right? All right, well, this is also the height, right? Now, this distance is 10, and so that means this distance right here is also 10, is it not? Okay? So the whole length of this to this is 24. So doesn't that mean that there has to be 14 left over from here and here? Because 10 plus 14 is 24. So if these two green lengths have to add up to equal 14, this has to be 7 and this has to be 7, right? It's an isosceles trapezoid, so those two pieces would be congruent. Now everybody, what do you see right here? You see a right triangle, don't you? Yes, you do. So you notice that you can do the Pythagorean theorem to find the height. 11 squared, you are my hypotenuse. You're on the right side all by yourself. Height squared and 7 squared goes on the left side, and we're going to solve for h. H squared plus 49 equals 121. Subtract 49. The height squared equals 72. We'll square root the height. So if we square root 72, that breaks up into 36 times 2. So it would be 6 square root 2. There is my height, everybody. My height is 6 root 2. So right over here, 1/2 times the height times the sum of the two bases. Good news. All right, now let's find our area. The area equals 1/2 times 6 root 2 times 34. Half of 34 is 17. 17 times 6 is 102. Square root 2, what's our units here? Inches squared. Inches squared. If you take 1/2 times 6 times 34, you get this 102 square root 2 inches squared. That's the exact answer. The approximate answer, when you multiply 102 times the square root of 2, is 144.25 inches squared. There's about 144 square inches that fit in this trapezoid. That's trapezoid and triangles. Let me know if you have any questions on those when you get to class tomorrow.